X is GCF. Take that out. What's left in the first spot? X, how many? Squared? Two of them, X squared. Because we took out one X, two more of them stayed. Does that make sense? Next, I would need 3 times what to get me back to 9? 3, how many X's stay? 1. And then last I got plus 2. Those 2. Can I factor this? Okay, we might come back to that. All right, any questions? Let's keep rocking. Go to the right. Example 2. It looks a little bit different. Do I see a common factor here, though?
X. No.
You're on the right path. Each one has an X. Yep.
What do you do?
Yep, exactly.
Oh, what?
You can add them together. These are the same.
Girl, what do you want?
All right, I guess not gonna say nothing.
Am I going green?
You finished? Just leave it there. Okay, so each term has a factor of X plus 3. It's the same as if each term had a factor of, let's just say it was times 2 times 2. They both got a factor of 2. I can take that 2 out, right? Process is the same. Each one has X plus 3 as a factor, so we can factor that out. So I factor out 1 X plus 3. What do I have left that I didn't factor out? X squared
And then
plus 5. Everybody follow that? They both had 1 to give, so I factored out. Takes me right there. What I didn't factor out was X squared plus 5. I could get back to where I started with, X plus 3 times this. That's this one. It's this one. And then 3 times X squared plus 5 would be this one.
that makes a lot of sense.
All right? See if you can do the one below.
Oh, do we need to turn in our study guides?
Yeah, if you did. Put that on my desk with your test. That one won't count you late because I just finished. All right, this time both terms have an X minus 7, right? So we factored that out. And we left behind 2X plus 3. And then like I said, once we start solving these, once you get it factored, you just set each factor equal to 0, and then we'll be able to solve. This is a little weirder, but everybody feel okay?
Yeah.
This is going to take us into our next technique. All right. So let's look at this next technique. If we start off with this expression right here, my first goal when I start looking at these, my first thought is there a GCF I can factor out? Is there a number that's a common multiple of all of these other than 1?
3.
3? Can you take...
No, 1.
Yeah. It's only one. None of these have a common multiple other than one. Everybody on board with that? Does each one have a certain number of x's they could give me? Does this 12 have an x that you can factor out? It does not. So the GCF, the greatest common factor here, is 1. How many terms are there? 4. When this happens, you're going to try to factor by grouping. Anybody remember hearing about that, Algebra 2? Factoring by grouping. Anybody remember what to do? No? All right, so we will try to factor out GCF. If it was a trinomial, we can maybe do the parentheses, which we'll do in a second. Don't have either one of these, so what you do is you write them in order, and you're going to take the first 2 terms and group them together. And you take the second 2 terms and group them together as well. Now you're going to look at each group and see if each group has a GCF you can factor out. A bracket? I don't know. It doesn't matter. I started using a bracket, but then I was like, let me use parentheses. That's why it looks weird. Thanks for bringing it to everybody's attention. I don't think everybody noticed, but it's all good. Okay, so for the orange one, is there a GCF here?
X squared.
Yep, you can factor out x squared. Let's do that. What are we leaving inside the parentheses? In the first spot?
X plus 4.
X plus 4. Okay. So now that I got this factor, it's starting to look like what we had over here. I want to factor something out in the second parentheses to make it the second grouping look just like this inside. What would I take out of this blue one? 3. 3 is a common factor. And when I do that, I get x plus 4 again. Now this looks just like what we just did, doesn't it? X plus 4 is my common multiple. So can I factor that out? Yeah. What did I leave behind? Yep, x squared plus 3. And that's factoring by grouping. We group the first 2 and the second 2. We look at each grouping individually, factor out a GCF, and a lot of times there's a factor in there that's hiding from us. Once you factor out that GCF, you can see it. Right? Questions how we got here?
How'd you get the last little part?
The x plus 4?
No, the...
This part?
Yeah.
This is like the leftover things. So we took out x plus 4, right? That's that. And then what we had left was x squared plus 3.
Oh.
Kind of like if you had 2x plus 2. You take out the 2, x is still there. And then this would be 1. 1 is still there.
Oh, okay.
So these things are still there. I just group them together. That makes sense? All right, I go below and I see 4 terms. I see I don't have a GCF other than 1. I'll try to factor by grouping. Sometimes these might be out of order, so just pay attention. You might need to write it in descending order, which just means you'll want like the highest degree term first, then you'll go down in terms of your degrees until you get to your number last. Okay, so we grouped the first 2 and the second 2, right? X cubed plus 5x. What did I say?
I'm confused.
No, what did I say?
No, it's gonna sound really dumb, so.
I mean, other people might have the same question.
Probably not.
Okay. Well, with the 4 terms, I don't have a GCF.
Well, no, I know that, but you said you had to like put them in descending order.
Yes. which means the exponent's 3, 2, 1 number. This is already in order. Sometimes like your 10 might be in front.
So before you do it,
Yeah, just rearrange them. Just put them in order. And I forgot a squared here. All right, what can I factor out of the first two?
X squared.
X squared. So I take out x squared. What am I leaving behind? X plus 5. So I'm thinking I want the second parentheses to end up being x plus 5. What would I factor out here? 2, yep. Positive 2. So then I got x 10 divided by 2 is 5. And now I see my common multiple. X squared plus 2, and then x plus 5. Yes. Great question. That's why I really like that. I was praying somebody would ask me that question. What are we doing with those two parentheses? Are we adding, subtracting, multiplying? Does the order matter when you multiply? Nah, I could do 6 times 2, or I can do 2 times 6. Both of them equal what? Either way. So to answer your question, the order does not matter. That's why I wrote it like that. You can put this x plus 5 here, you can put it behind, it doesn't matter, because it's all multiplication. Good question. All right, you guys take a second to do that one below. Yep. Do that one right below. All right, a squared minus 4 times, 3a minus 4 times a squared plus 3. Feel okay? Factoring by grouping. Any questions? All right, the one thing to watch out for, and you don't have to write this, but I do want you to see this in case it does happen. I just made this up. It's kind of like the first one. I factored out x squared from the first parentheses. The second parentheses is already what I need it to be. Everybody see that? So my common factor is x plus 5, right? What would be in my second parentheses? X squared, anything else?
Wait, what is this?
Yeah.
It says example.
Plus 1. Even though it's not written there, it's understood that your ghostly 1 is there. Okay? People, mentally, I would think to put plus like 0 or just leave it as x squared. But that would mean that it's a 0 here, but it's not. So you would need to put a 1 here, kind of like for a placeholder. So just look out for that. Not real difficult, just something to watch out for. If it was like -1, if it was like minus x plus 5, then this would be x squared minus 1. So even if you don't have to factor anything out of the second parentheses, you still need this placeholder right here. That makes sense? So just look out for those. All right, one more. You already know how to do this one, because we talk about it a bunch in this class. So hopefully we know how to do this. All right, so factoring trinomials. This is the one we've been talking about when we had to like find the domain and stuff. So when you got 3 terms, you factor into the parentheses, which is like doing the opposite of the full. So I don't know, I can show it and it'll make sense. We don't really have a name for it other than like factoring a trinomial. But that's when you do the 2 parentheses and you say, oh, what do I need to get me to r squared when I do first times first? Well, what I need in these first positions to get me back to x squared? R times R, first times first equals r squared, right? Okay, and then what was my process to find these numbers right here? Last times last. You guys remember? Because I listed factors of one of the other numbers. Which one did we always choose? Yeah, we list factors of the last number, 24, which are what? What are the factors? What 2 numbers can I multiply to give me 24? 1 times. Yep. 8. Yep, I heard a 6. 6 times 4, is that it, I think? Yeah, 6 and 4. I was going to say 4 times 6, but same thing. Okay, how do I know which pair I need? Yeah, it equals the middle number. So which pair is 2 away? 12 and 2? 6 and 4. Yeah, 6 and 4. 6 and 4 are 2 away from each other. I know the signs will be different because when I multiply, the only way I can get a negative is if one sign is positive, one sign is negative. So I know this is the pair I need to go with. 6 and 4. The order does not matter because we're multiplying. Which one should be positive? The 6, because I want the outcome to be positive. 6 is the bigger number, it needs to be positive. All right, and we just factored the trinomial. Some of you will want more detail, so we could write some stuff in here. You don't have to write this if you remember it, but some of you will want to, when you go work, you'll want to like a little definition. So what we did was we had 3 terms, so we were going to do the opposite of foiling, which is factoring. Obviously, first times first, just put your numbers, put your R's there. And then we look for factors of the last number. That I'll say plus or minus, add or subtract to equal middle number. And you can write more words if you need to. But we found factors of the last number, 24. We made a little list. And then we chose the pair that you can add or subtract to equal the middle number. In this case, we needed the pair that we could add or subtract to equal 2. And we saw if we did 6 minus 4, that came to equal 2. 6 times 4 gave me 24. All right, so as we work these, you might have to do a combination of 2 things. you might get a problem and say, you know what, this has a GCF. Let me take that out first, and then let me see where that takes me. So if we look at this one below, I think we have a GCF. What is it? Yep, I can divide all these by 2. That's the greatest number. And then each one has at least m to the first power to give me. So we start this one off by factoring out 2m. What's that leave us with? Yep, m squared plus 5m, yes, plus 6. Good job. I got 3 terms. Maybe I can factor this into the parentheses. What do I need in the first positions to give me the m squared? M times m. And then I need 2 numbers I can multiply to give me 6. That I can add or subtract to get me the middle number 5. Which pair do I need?
2 and 3.
Yep, 2 and 3. I see plus and plus, so I know everything needs to be positive. Plus 2 plus 3. And we just factored that. Like I say, in a few lessons, we'll be solving these, so you'll see like an equals 0 now that you got this. So if we started like this, that might feel overwhelming. Like, man, how can I solve this? It's got m to the 3rd power. What do I do? Well, you do these methods of factoring. Factor out the GCF, 2m, then we did the trinomial. Now I got 3 factors. This is a factor. This is a factor. This is a factor. I just solve each one and I will get my different answers. Does that make sense? All right. Just a heads up from this one. You could see a trinomial, like say we got, say just to kind of mix this up, and I'm making this up. But say we had like m to the 4th power plus 5m to the 2nd power plus 6. So these are the same numbers. I just took them from here. But notice the degrees are different. And you're probably saying like, man, what do I do now? Well, there's no GCF. I still factor it in the same manner, and it's all going to like work out. So before we would do m times m. When it's like this, you just do m squared times m squared. Before I said I needed 2 and 3. That doesn't change. But it'll work itself out for this middle term to be m squared. M squared times 3, 3m squared. 2 times m squared will give you a total of 5m squared. It'll all work itself out. The only thing you need to change is your first times first. Just make it squared instead of just m to the 1st power and m to the 1st power. So if you see these exponents get bigger, don't freak out. It's pretty much the same thing. All right, does that make sense? And another thing to look out for, watch out for when the middle terms maybe cancel. So let's say you have x squared minus 4. It may help to think about this as x squared plus 0x minus 4. And the middle term canceled out. That's why you don't see it here. So I would be looking at factors of 4 that when I add or subtract them, they cancel out. What would my factors of 4 be? Where it cancels out. 2 and 2, right? Because 2 minus 2 gives you 0. So that's what this would be. 2 2 and 2. And if you make the signs different, the middle terms cancel out. That's why you don't see a middle term here. But again, don't freak out. This is what you see. You guys got any questions on like those special cases? All right, any questions on factoring? All right, ready to shoot some hoops? All right, so what you can do is, let's maneuver, you can move around, get in a different group if you want to. Let's try to get in groups of at least 3, but no more than 5 people total. So you can stay where you're at if you want. If you want to move and go next to somebody you're normally not by, that's fine. But let's try to go from 3 to 5. From 3 to 5. Oh, you can take it. You want to scan with this group? Or maybe you can Hey, Ruth, don't move your back.
That's where you can service.
You just need to yeah. You can maybe, yeah, let me see. And honestly, all you need is a corner of the table. Well, you can move his desk or you can grab his chair. Yeah. But you know that. Let him sit right here. She's cool. All right, so first thing you gotta do is register your team. So basically this is how I know who's on whose team. When I look back in a couple days and I say, all right, let me put grades in for everybody participating, I'll know that the ballers were these 4 people or whatever, all right? So have everybody in your group write their name on this registration form, and you also gotta make up a team name. Right? Doesn't have to be anything crazy. Just something simple so we can recognize your team. So have everybody write their name so we all know who's on the team. And then come up with a team name. Some team names, because I know we need some inspiration. In previous class we had, there was a guy named Finn in the group. The team name was Finn Moves. One team's initials were Brew. They called themselves Brew James. We had no Shot Curry, no Chef Curry, I think, or something. We had the Ballers. We had the Underachievers. Y'all can do that. All right, listen. If you need help making the team's name, just let me know.